Hi, fourth graders. We've been working on multi-step word problems. And actually the other day we did Anthony's famous buttered rolls word problem. And I wanted to take a few minutes here to just show you what some of your fellow classmates did when they were solving this. So in this student, I see use models and has three children and four roles. I think that probably is. Now it would be nice if there was a little label here telling me what the models were representing, but I can still get the idea. I think probably those represent 2 adults and 3 roles, another set of 2 adults, another 3 roles. So he must have been counting up to the 12 adults and then found out how many roles they needed. After using model sum, I see that this student then transitioned into using some words for his labels. And down at the end, down at the bottom, I see a nice sentence answer. If a good rule of thumb, if you're being asked a question with words, you need to answer with words. The final question, the final answer will be a sentence. Okay, let's see another one. Another one of your classmates' work looked like this. So I see this student used a lot of labels, didn't they? And I see, if I follow along really carefully, I almost can imagine this person talking to themselves and walking themselves through the problem and probably referring back a lot to the problem to make sure that they were keeping it straight, finding out how many roles 2 dozen was, right? We had to find that out. We didn't maybe know right off the top of our head, keeping track of their totals. And if those were just numbers right there, it might be hard to know what that meant, but I can see he's thinking that might be the total roles needed. And down here, they're reminding themselves that they're short of a certain amount and gets a nice correct answer actually. Now, maybe there's errors in this. Maybe there's numbers that could have had a label, or maybe it's a little bit off. But what I do see about this is that you can see this person's journey. And when you have a complex problem like that, solving these math problems is a little bit like going on a journey. You don't know right away. You have to travel there. And so when you have these, you want to kind of get yourself settled, buckle up, and get ready for a journey, right? We can see the progression of what this student did and quite a bit of work that was involved. So that's just an example of 2 different ways that you could go about solving that type of problem. And I'll keep showing those when I come across ones that are uploaded and I can see them clearly. Okay, so let's go on to what we're doing today. You're going to be solving problems that really are that are great for using charts and formulas. And you'll see how we can make these complex sounding problems quite a bit easier. We'll also be using a strategy called guess and check, which is another good way to start when you're having to solve a complex problem. Anyway, let me go ahead and read this to you because the first step in any word problem is relaxing and just reading the problem like you're interested, just to know what this is about. Are we talking about elephants at a zoo? Or are we talking about a baseball game? What are we talking about? So I'm not going to stress. I'm just going to read it for one time. Amy's mother is 4 times as old as Amy is now. In 4 years, Amy's mother will be 3 times as old as Amy will be then. How old was Amy's mother when Amy was born? I read that and I think, I have no idea. Don't know off the top of my head. My very next thought is, okay, what do I know? Now I'm going to get into it and find out what each sentence is telling me, because without doing very much, I'm being told a whole bunch of information. So first sentence, Amy's mother is 4 times as old as Amy is now. Okay. So how can I write that in a way that's a little bit more easy to use? I shortened it to mom, first of all. Amy's mom is 4 times Amy's age. And I don't know Amy's numerical age, so I'm just going to write a blank, but I know that it's Amy's age. Okay. In 4 years, Amy's mother will be 3 times as old as Amy will be then. Oh, okay. I know from this sentence that 4 years are going to be passing in this problem. So I might make some type of chart or table or way to keep track of that. And then I also know at the end of 4 years, Amy's mother, and I might just use abbreviation, Oh, because it's right there. I'm sure I'll remember Amy's mother will be 3 times Amy's age. And that just sounds wild. It doesn't sound like it could even be possible almost. And then finally, they're going to want to know how old was Amy's mother when Amy was born. And that's going to be the final, but I've got a lot of things to tackle before I try to answer that final question. So let's dig in. Guess and check. You just, like it sounds, you guess a number that Amy's age could be. And you want to make it reasonable, right? So students, when I do this in class, they usually pick a number that will give an age that's reasonable for a mom, maybe 6. Maybe she's 6. So then 4 times 6 will get the mom being 24. And that's reasonable age for a mom, right? So in 1 year, the mom will be 25 and Amy will be 7. Then mom will be 26, Amy will be 8, 27, Amy will be 9, and 28, and Amy will be 10. Now, when you have a column like this, and it's all the same label, if I was going to label this mom's age, mom's age, mom's age, mom's age, mom's age, you can just give yourself some sort of label at the top, and you'll know that all of those are Amy's age. So now that we know how old they'd both be in 4 years, let's plug it in to my equation I made down here with the information I knew and see if it's true. So if Amy's mother is 28 and Amy's 10, is 3 times 10 the same as 28? No. So that, and I don't say, oh, I don't know it. I say, well, that's not it. Knowing what isn't the answer helps us get close to what the answer is. So I'm probably going to write somewhere on my paper what numbers, what age I just did, so I don't redo it. So we just had Amy being 6, so I might find somewhere on my page to record that. So as I'm working along, I don't do the same one again. Okay, another age that I see students pick, they maybe make Amy older, maybe 8 years old, and that would make the mom 8 times 4 is 32. So, and then I'm going to go through the same procedure. Let's plug it into the chart we've made. Mom will be 33, Amy will be 9. Mom will be 34, Amy will be 10. Mom will be 35, Amy will be 11. Mom will be 36, Amy will be 12. I take my information, I'm going to plug it into this other bit of criteria that we have, and I got this from the problem, so I know that this is a true statement. If the mother's 36, 36 is the same as 3 times 12. Is that true? It is. 36 is the same as 3 times 12. So we have found Amy's age at that beginning point. Now, all that data is going to help us find the final answer, which is how old was Amy's mother when Amy was born? We had to find out Amy's age before we could even begin to think about solving that part. But if Amy's mother was 32 when she was 8, what would we do? We would just have to take away the 8 and we'd find out the age, right? But what I want you to see is all of this, it was just for collecting data, right? And that's the only way we could have found out the age, but being able to follow these clues helped us narrow it down and find the answer. So when you're doing Baby Bird, I'm going to be interested to see what kind of charts or tables or labels or how you keep that organized and work through maybe guessing and checking and see what you come up with. Hope you enjoy it.